Okay, I'm back, and we have just been talking about different kinds of silicate minerals. What did they all have in common? Silicon and oxygen. So they were called the silicates. As a matter of fact, anytime that you see the word ate, that means oxygen. So silicon and oxygen silicates. So look at the next kind of mineral. They're called the carbonates. So what would they have? Carbon, and then the ate means oxygen. And so an example of that would be calcite. We've already mentioned it. So when carbon dioxide mixes with ocean water, it precipitates as calcite. And calcite is calcium carbonate. So it's got the calcium, it's got carbon, and then it's got oxygen in it. And another one is called an oxide. So that's another class of minerals. So it has oxygen in it. And an example of that was hematite, which is rust. So whenever something has iron in it and then it's subjected to oxygen, it rusts. And that's exactly what hematite is. It's basically rusted iron. So you see it's got iron, Fe, and it's got some oxygen in it. The sulfides have sulfur in them. An example of that was galena. That was that very dense mineral, and it's lead sulfide. Another one is called sulfates. So what does the word ate mean? It's got oxygen. So these minerals have sulfur and oxygen in them. And so an example of this is calcium sulfate, which you notice is kind of similar to calcium carbonate. The only difference is it's got sulfur in there. And that's called gypsum. And it is an evaporite. So when seawater evaporates, it leaves behind gypsum. It also leaves behind calcite. And it also leaves behind the next one, which is the halides. So halides means that they are some kind of a salt. And so halite is NaCl. Then you also have native elements such as copper. You also have hydroxides, hydro, so that means water. So an example of that would be limonite. And you notice it's this very long, complex formula, but then look at what it's got on the end of it, water. So limonite has water in it. And then you got phosphates, so it's got phospho, so that's phosphorus. And then it's got the word ate, so that means oxygen. So an example of a phosphate would be apatite, which is very important because apatite, you can get the phosphates out. And then what do we use phosphates for? Fertilizer. So this shows in that very last right-hand column the relative abundance of the various element or minerals found inside the earth. So you notice that the vast majority are silicates. And then there's about 4% is carbonates, and then oxides makes up 3%, and then the sulfides make up 3%, and then the rest of it is less than 1% of the crust is composed of it. Okay, so let's keep going here. Let's just look at some different kinds of minerals that are found in igneous rocks. So we haven't talked yet about igneous rocks, but igneous rocks come from a liquid melt, like magma or lava. And so these are some common minerals that you're going to find in igneous rocks. So at this point, don't worry about it yet, but when we get to the igneous rocks, then you're going to notice that their composition is composed of these kinds of minerals. Here are some minerals that are found in sedimentary rocks. So whenever you've got a rock and you subject it to rain and wind, you break it apart into smaller pieces called sediments. And then when those sediments are glued back together again, these are the kinds of minerals that you're going to find in those sedimentary rocks. And then here is some minerals that you would find in metamorphic rocks. So if you take any kind of a rock and you subject it to pressure or heat or hot liquids, then what can happen is you change the minerals that are in the rock, and in doing so you end up with different kinds of minerals. So those are the minerals that you might find in a metamorphic rock. So at this point, don't worry about it. I just want you to see that different kinds of rocks have different kinds of minerals in them. Here are some minerals that come from weathering. So if you take, for example, rocks that have lots of iron in them, they turn into hematite. So the minerals in those igneous rocks, which contain lots of iron, they weather and they will turn into hematite. Another one is kaolinite, which is clay. So a lot of these minerals will turn into clay when you weather them. Then these are ores. So an ore is going to be a type of rock or mineral that you are going to extract metal from. And so these are different kinds of ores. And so notice that we can get iron out of hematite. We can get lead out of galena. So different kinds of minerals give, when you melt them down, will release different kinds of metals. Oh, and then apatite it doesn't release a metal, but remember it was made of phosphorus, so that meant that when we break it apart, we could use it for a fertilizer. All right, let's take a break, and when we come back, we're going to talk about how to identify minerals.